so what we're going to be looking at today is the first set of notes in 5.5, which is operations on functions. So this is in your student journal on page 145. Okay, so operations on functions. We're going to be looking at these four here. So today we're just going to do these three, and division we'll look at tomorrow. So essentially we're adding, subtracting, and multiplying two functions together. So this is just like you're taking one function and adding it to the other, or subtracting or multiplying. So you're doing any distributing, combining of like terms that you can do. So basically just all the algebra that can be done to simplify them as much as possible. And then a lot of times once we get that simplified, we're going to be looking at what is the domain of the simplified function, and then substituting in a value into that new function. So let's jump down to page 146 then. Okay, so we're going to be looking at number 1 here. So they give us two functions, f and g, and we want to add the two functions together. So this is the notation we'll be using for that, and subtract them. So that's our notation. We're going to be looking at the domain of each. And then they ask us to plug in for the given value of x, which is the third thing they tell us they're negative 1,000. So let's look at adding the functions together first. So f plus g of x is the way we would say that. So I'm just going to take my function f, negative 1/2 times x, and I'm going to change that to rational exponent notation, the cube root there, plus my function g, 9 over 2 x to the 1/3. And then I'm going to simplify. So this one is pretty basic because they're both just x to the 1/3. So I can add those coefficients. So 1/2 plus 9/2, or excuse me, that should have a negative on it, sorry. So negative 1/2 plus 9/2 is 8/2 x to the 1/3, or 8 over 2 is 4x to the 1/3. All right, and then they ask me for the domain of that. So what I want to think about is when we were graphing these, anytime I had something that was a cube root, so remember the cube root functions look something kind of like this, where they go forever to the left and forever to the right. So I'm going to say my domain is negative infinity to positive infinity. Okay, let's look at the same thing with subtracting. So this is f minus g of x, and this is the same idea. So I'm going to start with f minus g. So this is the same except for one little sign is different. So negative 1/2 and negative 9/2 is just negative 10/2 x to the 1/3. So this is negative 5x to the 1/3. Okay, so same idea. I'm going to think about the domain. This is still just a cubic function. That negative 5 is just going to be a vertical stretch and a reflection, but it's still going forever left and right. So my domain is negative infinity to positive infinity. All right, the last thing they asked me then is substituting in a value. So that negative 1,000. So they want me to find f plus g. Now instead of an x there, I'm going to put in negative 1,000 because that's what I'm plugging into my function. So that would be 4, and instead of x, I have negative 1,000 to the 1/3 power. So the cube root of 1,000, so what number do I multiply by itself 3 times to get negative 1,000, is just 10, and since it's negative, it'd be negative 10. So this is just negative 40. Same thing for f minus g of negative 1,000. So I'm taking that function that we made, so the negative 5, negative 1,000 to the 1/3. So same thing, the cube root of negative 1,000 is negative 10. Only this time I'm multiplying by negative 5, which would be 50. All right, let's look at another one, number 2 here. So this time no rational exponents, but I do have some x's and x squareds. So same directions. We're going to find f plus g of x first. So f is negative x squared minus 3x plus 8, plus g is 6x minus 3x squared. So I'm just going to be combining like terms here, negative x squared and negative 3x squared would be negative 4x squared. 6x and 3x is 3x. Plus 8 was my only constant there. Okay, so I want to think about the domain now. So this is going to be some sort of parabola. It has some vertical stretches, and it's left, right, up, down somewhere, but I know generally it has this shape. So that does go forever in both directions. So my domain here would again be negative infinity to positive infinity. Okay, let's think about f minus g of x now. So same idea, I'm going to take f just as it is. Now this time, when I subtract g, this means minus 6x minus 3x squared. So that negative has to be distributed to every part of g. So this is minus 6x plus 3x squared. So really it's just changing the sign on every part of g. So when I simplify here, I have 3x squared and negative x squared would be 2x squared. Negative 3x and negative 6x is negative 9x plus 8. So again, I would have a parabola. This one just happens to be pointing up. Either way, my domain is still going to be negative infinity to positive infinity because it's going forever in both directions. All right, they then want us to evaluate at negative 1. So I'm going to find f plus g of negative 1. So that means I'm going to go to my function, and everywhere I see an x, I'm going to plug in a negative 1. So I have negative 4 times negative 1, plus 3 times negative 1, plus 8. So let's see here. Whoops, I forgot the squared. So negative 1 squared is a positive 1, so this is really negative 4 minus 3 plus 8, which is just 1. We're going to do the same thing with f minus g of negative 1. So I'm going to that new function that we made, and I'm plugging in negative 1 anywhere I see an x. So here, negative 1 squared is a positive 1, so 2 times positive 1 is just 2. Negative 9 times negative 1 would be a positive 9. So this is just 19. Okay, now that you kind of got the idea, I want you guys to try number 3. So go ahead and pause. Try doing f plus g of x, f minus g of x, doing the domain for each of them, and then plugging in 2. So pause the video, go ahead and try that, and then come back and see how you did. All right, so you should have found that f plus g of x is x to the third plus 2x squared plus 21, where the domain is negative infinity to positive infinity. And then f plus g, when you substitute it in 2, then 37. F minus g of x then was 7x to the third minus 2x squared plus 3. Same domain. And f minus g of 2 was 51. Okay, we're going to try just one more, adding and subtracting one another one where we have those rational exponents in here. So, same directions then. So number 4, f plus g of x is going to be the 5th root of x to the 1/4 plus 1 plus negative 3x to the 1/4 minus 2. So combining my like terms, since they're both just x to the 1/4, I can combine their coefficients. So 5 and negative 3 would be 2x to the 1/4. And combining the constants, positive 1 and negative 2 would be a negative 1. So when I think about this one here, I have to think about what can I plug in for my x values. So I know that the 4th root function is similar to the square root function, and that it has kind of this shape. So my domain is restricted. I can't just do negative infinity to positive infinity. So what I want to think about is, did this function move left or right at all? So I know that 2 is going to be a vertical stretch. I know the negative 1 is going to be down 1, but overall my domain is not changing. So it would be the same graph here, but down 1. So my x values have to be 0 or higher. So my domain is x is greater than or equal to 0. Okay, let's see what happens when we evaluate this function at 1. In other words, we plug in 1. So I would have the fourth root of 1 is just 1. 2 times 1 is 2 minus 1. So it's just 1 here. Let's look at the subtracting then. So first we have to find f minus g of x. So that's 5x to the 1/4 plus 1. And the signs are going to change then. So that negative 3x to the 1/4 is now positive 3x to the 1/4. That minus 2 becomes a plus 2. So I have 8x to the 1/4 when I add, plus 3. Okay, so I have to think about the same thing here. So this is going to be a fourth root function with a vertical stretch of 8, and it's going to be up 3. So domain-wise, that function isn't moving left or right at all. It's going to be somewhere up here like this. So again, my x values are going to have to be greater than or equal to 0. Last thing then, f minus g of, we were substituting in 1, is going to be 8 times 1 to the 1/4 plus 3. 1 to the 1/4 power is just 1. 8 times 1 is 8. 8 plus 3 is 11. Okay. We're also going to look at multiplying today. So in these directions, it's the same exact thing, only multiplying and dividing, stating the domain, and then you're plugging in another value. We're going to do just the multiplying parts today and save some room here because we're going to do the division parts tomorrow then. So we're going to look at number 6. So just f, this is how we would write f times g of x. So this is just like we did in the other ones, only we're multiplying. So we have 12x times 11x to the 1/2. Okay? So what you want to think about is, let's go ahead and get those coefficients out of the way. So I'm multiplying 12 times 11, which is 132. And now I have x to the, I'm going to write this as x to the 2/2, because I know when I multiply things with like bases, the bases are both x, I need to add the exponents. And to add those exponents, I need a common denominator. So x to the 2/2 is the same as x to the first. So I'm going to write it as x to the 2/2. So this is now then 132 x to the, when I add those two exponents, 3/2. So when I think about this, I need to look at my root, which is 1/2. So anytime I have that root of 1/2, my domain is going to be restricted. And since this isn't going left or right at all, it's just kind of like the last ones we looked at, x has to be greater than or equal to 0. Okay? They now had us evaluating at an x value of 4. So 132 times 4 to the 3/2. So 132 times the square root of 4 to the 3rd, which would be 132. The square root of 4 is 2. So 132, 2 to the 3rd is 8. And finally, 132 times 8 is 1,056. All right, the last one we're going to do here is number 8. So same idea, just the multiplying pieces. So f times g of x equals 36x to the 7/4 times 4x to the, now I'm going to change that 1/2 to be 2/4. So it's still equivalent, except for I now have a common denominator with my fractions there. So when I multiply here, 36 times 4 is 144, and I get x to the, I have two things with the same base, so I can add the exponents. That'd be 9/4. Again, my domain is going to be x is greater than or equal to 0 because I have that fourth root. And then I wanted to evaluate at 16. So 144 times 16 to the 9/4. So 144 times the fourth root of 16 to the 9th. 144, the fourth root of 16 is 2. 2 to the 9th is 512. So when we multiply, we get 73,728. Okay. So when you do this homework, anything that's dividing, you can just hold off on and do the multiplying ones just like this. And dividing we'll save for tomorrow.